This is the notes for 1.7, inverse relations and functions. To find an inverse function, algebraically, you're going to switch the x and the y in the function and solve for y. Graphically, it's reflection of the line over the line y equals x. So the first thing we're going to have to look at is the horizontal line test. This tests to see if the function is 1 to 1. So when you see that wording 1 to 1, it means there's one unique y for one unique x for each one unique y. So they have to all be separated. A function has an inverse that's also a function, which you'll see in this notation. So if you see f to the negative 1, you know that I want your inverse to also be a function. They have to pass both the horizontal and the vertical line test. So here are my 3 examples. There's one here, there's that graph, and then there's this one that you haven't done yet and we'll do later on in the year. So if I want to see if I'm going to be able to find an inverse, so before I even actually find an inverse, I have to check to see if it's 1 to 1 and has an inverse. So first I have to do my vertical line test, which passes the vertical. And then I'm going to do the horizontal and see if it passes the horizontal. So as long as it passes both the vertical first and then the horizontal, it does have an inverse. So yes, it has an f to the negative 1, and you mathematically can find it. If I do this one, if I do the second one, which is a quadratic, it passes the vertical line test, but it's going to fail the horizontal line test. So that means no inverse that's a function. Then when I check the third graph, which is an arc function, we're going to do those later, it fails the vertical line test. So I don't even need to check the horizontal line test because it has to pass the vertical test. So there's no inverse that's a function, unless you do restrictions, which we're not going to do right now. We'll do those later. Okay. So the first thing we're going to do is we're going to look at the example x squared minus 2 and find f to the negative 1 if possible. So first you need to know what your graph kind of an idea looks like. X squared minus 2 is a quadratic, looks like this. It will pass the vertical, but it is not going to pass the horizontal. So there's no inverse. Okay, you might just want to keep this in mind when you're doing your tests later on, that we might ask you questions like this, and it looks like you have a lot of them, but we want to see if you understand this. So make sure that you remember this. The next one is a rational function, and your rational functions are going to have them. So we're going to find f to the negative 1. So we're going to do that by first changing your f of x to y. And then we're going to switch your x and your y. Okay. Now we need to get y by itself. So in order to do that, we're going to have to multiply 3 minus 2y times x. You're going to have to do some math. Distribute, that's 3x minus 2yx equals 2 plus 5y. Now I'm going to get all my y's on one side. So I'm going to move 3x, I'll move my 2 to the left and my 2yx to the right. And the reason for that is these have an x, so I can factor, I have a y, so I can factor out a y, because my goal is to get the y by itself when I'm writing my functions. And then my y is 3x minus 2 over 5 plus 2x. So my inverse is 3x minus 2 over 5 plus 2x for that. Okay, composition of inverse functions. If two functions, f of x and g of x, are inverses of each other, then your f composed with g, your g composed with f equals x. So it only equals x, no other letter, no other number. So if I ask you to determine using compositions, not by finding the inverse of 1 and seeing if it matches, I basically want you to do a proof and prove that f composed with g, g composed with f gives me x. So first we're going to check f composed with g. So I'm going to plug my g into my f. And simplify. So my cubes will cancel out, or cube roots will cancel out, and I'm left with 2 times x plus 6 over 2 minus 6. The 2's cancel, 6's will cancel, and I'm left with x. So that one is fine. Now I'm going to do the other direction. I'm going to do g composed with f of x, and I'm going to check my f into my g. And you need to check and make sure that you do both of them, because sometimes one will work based on the kinds of equations you have and the other one may not. So now I'm going to plug 2x cubed minus 6 plus 6 over 2. The 6's will cancel, the 2's will cancel, and I'm left with cube root of x cubed, which gives me x. And so, yes, they are inverses of each other. For that. Let's see if there's anything else. That's the end of 1.7.